All right, welcome back. So here I have the sandbag that I went and textured inside of Substance Painter. Again, the Substance Painter project file comes with the course, so you'll have access to it so you can check out how the layers are all set up. So I actually did go and do a little bit of high-res modeling. I didn't do a ton, but I did want to walk through just what I did so you guys could see. Let's go in and start to take a look. So you can see I went and converted it to a pretty rough VDB from polygons, then I just converted it back to polygons and got a nice high-res mesh to start working with. Now again, like I always tell people, you can all just take this and bring it into ZBrush now and do that. Look, I mean, that is quite a bit of modeling. And the cool thing about it is you can go and change all these parameters and just get another bunch of variations of sandbags that you can use inside of this particular sandbag wall tool. Okay, and then I just went in and what I did to get the pattern in here is I used so if we take a look, I used the boxes pattern. Alright, so I just took the current position vector to float so I could get the X and Z position, so I could basically treat those as the UVs for the boxes, and it lays it out nicely. Turned out pretty cool, gave it a more of a fabric type look. I also went and created a seam edge. So what I did is I selected the ring around where the seam would be, and I used the edge group to curve node. And what that does is it gives you a nice tube that you can use. And I basically then just merged that together with the actual sandbag that we modeled to get that shape. All right, so now it looks more like a bag that's been stitched together. It's pretty rough, but I am trying to make a more of a stylized look to this whole thing. So then, yeah, I added the boxes noise and then just kind of smoothed it out a little bit more. It's probably a little bit too much. You can always go back and change it though. So that's what I did. All right. So let's actually move forward and start to work on the actual tool that's going to lay out the wall and take care of stacking the sandbags and staggering them appropriately. So I'm going to create a new geometry node, and this is going to be called the sandbag wall. And let's go and just create the digital asset since we're here. And I'm just going to call this GT sandbag wall. There we go, just save it into my OTL folder. Okay. So this allows us to at least get a nice clean start. So I'm just going to go and hide all these guys. I don't need those. All right, so since we don't have any parameters, we are good. The one thing we could do right off the bat is just set up the operator path to import our sandbag object, like so. All right, and we'll just set that to any SOP. Okay, so what I'm going to do is drop down a curve node, and we are going to allow a user to input a curve, but for now this is just going to be our curve, so I'm going to leave it fine for that. And then I want to merge in that sandbag, so let's get the sandbag low. That's the one with the textures on it. And I'm just going to name this a sandbag object. All right, so now we should have our sandbag in here. Cool. All right, so I just want to go and draw a curve. So I'm going to draw a curve with my grid snapping turned on, keeping in mind the scale that I'm currently at. So we'll do something that's relatively large. So let's go and make some sort of shape. Now I'm not going to go and make this adhere to any sort of unit grid like we did with the wooden wall, because I want users to be able to place this wherever. All right, so you can just put sandbags wherever, because we're going to use this particular tool for in a lot of places for the final guard tower. All right, so let's go and make sure, well, we can leave it open for now. I was going to go and close it, but this is fine for now. The next thing that I want to do is go through and actually cut it up into individual pieces, so we get a primitive for each particular line here. Because currently, if you look, It's only one primitive, that little 0 right there. So to do that, we use that polycut. So the first thing I'm going to do is group, and just group all the points. So we'll call this all points. Alrighty, set it to points, and we'll do a polycut. Alright, so I'm going to put the all points in for the cut points and just say cut, and that gives me a primitive per line there on the curve. Alrighty, so then what we want to do is do a loop. So I'm going to do a for each primitive, so we can loop through each one of those primitives. Alright, and I like to set this to single pass just so I can go through individually. So the first thing I want to do is do a resample. Okay, so I'm going to resample this, and this is going to be a specific size, and that size should be the size of the sandbag. So we can do the, and let's take a look. We modeled this in the Z direction, so that's always going to be the longest length there. Let's turn all these off there. Alright, so what I want to do is get the size of that sandbag, so our points are spaced out according to that size. So I'm going to do a BB box and get the sandbag object, and we'll do the DZ size. Turn our points back on, and there we go. So now we have the correct spacing. If we template this here, it looks pretty good. Looks right. When we go and copy it, we'll be able to see. Okay, so now we have those, and what I want to do is a point jitter, because I don't want all these guys just to be, whoops, I don't want all these guys to be just laid out completely straight. We want it to look like humans actually stacked this thing. Alright, so that's definitely way too much. As usual, it's pretty powerful right off the bat, and I'm going to take off the Y, because I just want to perturb them in the X and Z direction. Cool. There we go. All right. So at this point, let's actually produce some normals. So I'm going to do a polyframe. And we'll set it up so the normals actually flow with the direction of the curve. I'm going to do two edges, points, and turn our normals on. There we go. So there we go. So now the normal is traveling along the curve, which is good because when we use the copy to points, we want that direction information to be applied to each copy. Okay, so now that we've got that, I want to create the height of the wall, so I'm going to do a copy transform actually. All right, and this will allow us to copy this upwards. So what we're going to need to do is get the height of the sandbag that we're using. Alright, so again, we're going to use that BB box, and we'll get the sandbag object, and we want the DY size. There we go. So that gives us the height. And then what we need to do, and we can actually get this kind of going so we can see how everything is turning out. I do like to do that while developing these. So let's go and create another for loop. What we're going to do is we're going to say for each point here, all right, we are going to copy a sandbag onto that particular point. There we go. And I'm going to say copy to points. There we go. We'll hook this guy up like so. And now we have sandbags. And they're all being nicely perturbed. Looks pretty good. They do look like they are, oh no, they're perfect, yeah. Some of them are intersecting each other. So you could always go in and add a little offset. All of their normals are all messed up too. Let's do a normal node. There we go. We can go in and add a little bit of an offset as well. You could do it here, so you could do something like, let's see, what. Oh, and that is also because we need to be forward over here. So it's always a good idea to pick a good pivot point. In this case, I want it to be at the end of this, since we're basing all of our offset sizes on the dimensions of this. So what I want to do is push this forward. So I'm going to, in Z, right, I'm going to do $Z min and then just do the negative of that. And that'll make it sit right at the bottom there, or at the end of that sandbag. All right, let's take a look. That's better. Yeah, looks a little better. Okay, and we'll turn all these guys on. Let's take a look here and see what we're getting. So we're not too bad. The only thing that we need to take care of is how the walls actually interlock with each other when they reach a corner. Right now we're currently getting this overlap, and the bags are just stacked on top of each other, which isn't how they work. They stagger them so it has more stability, right? So what we want to do is first take care of this overlap. So we just don't need the end point in each of those line copies. So if we take a look here, we just don't need the last point. And so what I'm going to do is do a group by range and set this to points. So we'll just call this end point. And we'll just add 1 to that end and invert the range, and now we have the endpoint. So then I'll just blast it. Like so. We'll say endpoint. Yep, get rid of the endpoint. Cool. Let's take a look. Or maybe actually we wanted the start point, so I did the wrong one. So let's just rearrange this. So we want this one. There we go. Perfect. So now we've gotten rid of the overlap. We just need to take care of the interlocking portion here. And that's all done through just staggering the lines themselves. So let's take a look. And I'm going to do a little bit of X for this. And the reason why I'm doing that is just because I'm more comfortable with it, and it allows me a lot more control and a lot less nodes to keep track of. So I can do a lot of work inside of just a single node. And I'm not going to do a ton of code here. So it's good practice to start getting into the habit of using the Vexes. They're faster in the Houdini engine as well. So let's do this. All right, so the thing that I want to do is per copy is I want to basically stagger these. So I need to offset these guys for each copy. And what we can do to get access to each copy is create this copy number attribute right here. So I'm going to check that on. So we have this copy num, and if we go into our geometry spreadsheet here, come on, there we go. We now should have a copy num on each primitive, which is great because now what we can do is do an attribute promote. So I'm going to start typing up promote, get an attribute promote, and I'm just going to promote that primitive to a point. Let's do the maximum, I think. Should work. So if we go to points now, we've got the copy num. Yep, so each point now has its copy number on it. So for each one of the points now, what we can do is we can stagger them. So we can push them along their normal there. Okay, so what we want to do is first we want to create an ID. So I'm going to type out an int called ID, and this is going to be equal to the copy num mod 2. So basically the remainder of whatever copy num currently is divided by 2. So this is going to give us the remainder. So basically what happens is per point you get this pattern of 0, 1, 0, 1, 0, 1, right? And we can do that. We can basically use that information to figure out how to stagger it. So the zero primitive, sorry, I'm trying to sit here and explain it, but the 0 primitive is going to be pushed forward. This primitive right here, this line in the middle, is going to be pushed backward, and then this one's going to be pushed forward because it's going to go 0, 1, 0 kind of thing. So long explanation. So then I want to do that offset amount. So I'm going to create float offset is equal to CHF, and we'll just call that offset. Like so, and this is going to allow us to actually control it. So I'm going to expose it by hitting this little guy right here. And let's just put an initial value like 0.1. So now what we're going to do is say if the point number, or no, if the ID is greater than 0, meaning it's 1, then let's push the line. If not, then we're going to leave it where it's at. So let's say at p plus equals the normal direction times offset. So that offset value. And you can see what happens is now we're basically pushing that middle one forward. And if I were to create more copies, it would stagger it. There you go. Because it's going 0, 1, 0, 1, 0, 1 by using that mod method. All right. So I'm just going to leave it at 3 for now. It's working out pretty good for us. Okay. So what I also want to do is actually push it back, because if we take a look at this now, let's just take a look here really quick. Let's turn all the components off again. We're getting the staggering, which is cool. So let's just take a look. So we can stagger this a certain amount. But we're still getting a little bit of an offset. So what I want to do is add an extra push, because I need to push everything back. So basically it just staggers it based off the center of this whole side of the wall, if you will. All right, and to do that, I'm just going to take every point. So at p minus equals at n, so all the points together, times offset. There we go. So now we're starting to get that interlocking there. There we go. So you can see how it's starting to become more of a modular type tool, or a modular way to lay out the sandbags themselves, even though they're still kind of floating a little bit. And what I want to do is go in and add a little bit of noise to all of this. So we're going to do that here pretty soon. I think I'm going to add an offset now to the height right here, this height that we're doing. So I'm going to say minus 0.1. So what we can do is expose that to the tool so people can decide how squished these guys are together. But at least it starts with that default value of the height, or the size of the sandbag itself. Cool. All right, it's starting to work out pretty good. I want to add one more value here. So I'm going to do at p plus equals at n plus chf. I'm going to call this the push attribute here. I don't know, I'm just kind of negating that there. So let's see what happens here. Nope. I wonder if we did a multiplication. That seemed to work out pretty cool too. I mean, that's what we originally had, just as an extra little offset. Some of these guys seem like they're a little offset. So you can go in and, actually on a per point basis, kind of fudge them back and forth a little bit too. So we can do something like on a per copy basis. What I can do is push each one back and forth a little bit. Just randomize that number. So let's say now we're going to need the meta import node. So we'll just call this the loop data. And we'll stagger z. We'll just call this rand transform. And what I'm going to do is do a rand of the detail attribute. All right, so we'll get the loop data, and we want the iteration. And there we go, times some random number. And then I want to do a fit around that. So fit, we'll say 0 to 1, and I want the min and max to be maybe something like 0.1 to 0.5. And now you can see they're all offset. And so let's do something like, let's not do all positive, so 0.5 and in the negative as well. So now you're really messing it up. It's just probably a little too intense there, so we'll do 0.1 and 0.1. There we go. So, anyways, there's a lot of other types of. I mean, you can go in and really start to randomize all the different properties. The other thing I wanted to do is come in here. So I'm going to grab all these guys here and just pull these guys up here. And what I want to do is drop down a point node and add some noise to the lines themselves here. All right, so I'm going to do a mountain. All right, and if we show the height there, you can see that they're being pushed in and out based upon their normal there. So you can change the element size on that. That's pretty cool. Let's see what that looks like. This is what I do a lot of the times. I just kind of mess around with the ideas. Now it's always silly. Oh, and the normals are all messed up. So you got to do another polyframe. Like so. Oops. There we go. Put that on the points. And let's take a look again. There we go. At least that took care of all the directions. So now when we change this mountain node, we're getting a noise for the displacements as well. As you can see, though, once you start to layer on too many of these particular randomizations and offsets and stuff like that, it can get a little hard to control. So I'm just going to turn this guy off here. It cleans it up nice. So we'll just do it all with the mountain node. So that could be the rand normal, right? And then we can go and drop down another point node, and we'll set all the normals to, I don't know, let's say up. So we'll set them all up. 0, 1, and 0. There we go. So they're all pointing up, so we can pass that into another mountain node and just perturb them in the up direction. So you get more waves of the sandbags. Definitely make that a lot larger in the element size there. And okay, there's one last thing I really want to do before I close this out. You'll notice that because we did that, it looks cool. Definitely looks cool now that we're getting the undulations in the sandbags. But you'll notice now that some of them over here, these guys, they're all rotated like crazy now. And that's because what we need to do is build the proper directions for the lines themselves. So let's go and do that. Let's actually select all these guys and just pull this down here. And I'm going to do another wrangle node. Okay. All right, so I'm going to try to walk you guys through this as best possible. So I'm going to take the current, or I'm going to create a new vector called the flat direction, because I want to flatten out the current normal that we have up here, right? And because we perturbed them in the y direction, they're pointing up and down in y a little bit now, so it's messing with the rotations of each copy. So I'm going to flatten out the normal by assigning the current normal to this new variable right here, and then we're just going to say flatdir.y is equal to 0, and that'll flatten it out. And then we want to build the right direction, so I'm going to say the cross product of the flatdir and the world up vector, so 0, 1, 0. That gives us the right direction. And where did I go wrong? Oh, this needs to be lowercase. Yes, there we go. All right, so then we can go and actually visualize that using a visualize node. And set this to a type of marker, make it a vector, and we will give it right. There we go. That doesn't look completely right because these guys should be. Do I need to put in at right? Nope. let's see what happens. It's showing up here. So let's go back to our visualizer here and let's get rid of the @ symbol. Retoggle this here. There we go. Yeah, just needed to actually declare the type. All right, so now we have the right direction, and you can always go and style these things a little bit more. Just do the traditional red, green, and blue. There we go. Maybe make it a little smaller. Cool. So now we just need the up vector. So v at up is equal to the cross of at right. So the right and the current normal. Okay. And we can visualize that guy. So let's do up. There we go. So now we have the proper up vectors. So now what we can do is pass that in, and the copy to points node is actually looking for those two particular parameters. So if we look at our sandbags now, they should all be oriented correctly. There we go. And they're following the flow of everything. So there we go. That's how we make a sandbag wall. I'm going to work a little bit more on it, try to clean up some of the spacing, but that's the general idea, right? So now you can go and change the positions of the curve, stuff like that. So you can come up here and let's say we do an edit node here. Do we get it? There we go. Just move the points around and you can see it's building the wall for us. A lot faster than doing it by hand, that's for sure. And it's also much more flexible than creating, these individual modular static models that you have to place by hand. So there we go. So that's what I wanted to show in this video. In the next video, I'm going to wrap this guy up and put it into Unity so we can test it up. Thanks so much.